The problem is everyone knows Pydantic validation. It is kind of ubiquitous. It's downloaded now. We crossed 500 million downloads last month. We are top 20 most downloaded Python packages. If you remove transitive dependencies, we're kind of top 3. So it goes requests, NumPy, Pydantic, roughly, in terms of non-transitive dependencies. And well, I suppose, how many people in this room use Pydantic or are on a team who use Pydantic? Basically everyone. But Matthew, you work for Pydantic. OK, fine. So what Pydantic does is enforce type hints, effectively. And as well as validating them, it also coerces. So you see we have a list here with some strings, but the input type should be a float. We can go and run validation, and sure enough, we'll correctly coerce that thing to a tuple and to floats, and we can do numerous other coercion, and we do stuff like JSON schema. And Pydantic has been around since long before Gen AI. So it started in 2017. It was picked up by Sebastian at FastAPI in like 2018, 19. So it's very widely used outside of AI. But one of the things people realized is that this is very useful when you're trying to do structured outputs from LLMs. And so OpenAI and companies like LangChain went and picked up Pydantic and used it to enforce types in tool calling. I was very proud of that until I got to the end of last year and we started to build AI stuff into Logfire, and I realized that those libraries are, I'll be tactful given the intro I got, but they are not type safe. And I think in the JavaScript world, like TypeScript has total victory. No one would even think of starting a library in JavaScript. You would always use TypeScript. Crazily, we're in a world where there are still those people who think it makes sense to write untype-safe Python code. And there is no other, to this day, truly type-safe agent framework apart from Pydantic AI. And so we went and built Pydantic AI, which you see an example of here. Hopefully you can see that code. The fundamental type here is this agent, which performs the... So I say there are 3 definitions of agent. I know that those people who've been an AI engineer will have heard people banging on about what is an agent. So I apologize to those people, but for everyone else, there are sort of 3 definitions of an agent. There is the AI person's definition, which is an LLM calling tools in a loop. There is the infra person's definition, which is a microservice. And then there is the business definition, which is something we can use to replace a human. This definition of agent is obviously the AI one, which is effectively a type for an LLM calling tools in a loop. In this case, the tool we're calling is to do structured outputs. So we have a city type. Fun fact, OpenAI does not support tuples, so we've used a type dict. And if we go and run this, and the gods of demos are with us, we will go and successfully extract some structured data from this sentence. We do a bunch of other stuff. We take type safety very seriously, so you will see here in this same example, you will see that agent is generic in the output type, city here, which means that result is in turn generic in city. So result.output is both a runtime and at typing time an instance of city. And if we access first name, you would get an error. And if you access name, all will be good. Now, again, for those of you who come from a TypeScript background, this does not seem surprising. For those of you who've used other agent frameworks in Python, this is, it turns out, novel, amazingly. We also do a bunch of other stuff like durable execution well, so we use temporal. So if we look at the ramp example, you would get the durable execution out of the box if you built it with Pydantic AI without having to implement that. We do great MCP integrations, which I will show you in a moment, and some other things. The next thing we have is Pydantic Logfire, which is how we make our money. So it's an observability platform. It is general observability, but we have first-class support for AI. I do not believe that the term AI observability will be around in 5 years' time. If you're positive about what's going to happen to AI, it's going to be used everywhere, and we need one platform to do both general observability and AI observability. There seems to be an awful lot of people building AI observability. Only us and arguably Datadog, who are not doing it very well, are trying to build general observability with AI. But here you see, we take the previous example, we add in these 4 lines. So we have import Logfire, Logfire configure. This is our SDK, but under the hood, this is just using OpenTelemetry. So there are those people who take Logfire SDK and send the data to other inferior observability platforms, but that works. That's the nature of us building on open standards. And then we have logfire.info, which is going to be a log. Actually, it'll be a zero duration trace span in this case. And yeah, we do neat things like extracting values from f-strings, so you can use f-strings when you're logging, and we'll not only extract the value, but we'll also extract the key, and we'll have that expose that to you as structured data. So if I go and run that example again, you'll see here we switch model. One of the nice things Pydantic AI gives you is the capacity to switch between any of the major models in one line of code. If we go and run this, as well as the successful output, you will see this link to Logfire. So if we go and look at what that looks like in Logfire, it's not a very interesting trace at this point because there's only 2 spans, but we have the nice view of the LLM exchange. And you'll see on the log line, we have not only we have the structured data about the city, and we could go and query on that if we wanted to. And then the last bit of what we do, wrong window, is Pydantic AI Gateway, which has been out for all of 1 week. So so Pydantic AI Gateway is arguably just another gateway built by us, though. The main thing we don't do is try and unify to a single API format, like most of the other gateways do. I think that is a doomed endeavor in many cases. And given that we think a lot of usage will be through Pydantic AI, Pydantic AI already takes care of that unification bit, so we don't need to. So the only change I've made to this example is putting in the gateway prefix. And of course, again, go and run it, and we can do the same validation. Okay, so those are the 4 things that we do. Now I actually get on to the demo, where I'm going to talk about one of the new bits of Pydantic AI and also MCP, and I will try and touch on FastMCP as well. So we have support for 2 UI stream protocols, AGUI and Vercel's AI protocol. The idea here is you don't need to go and build a full front end for your application if you want to have the chat interface. Even if you do want to go and build that full front end, you don't need to worry about implementing a protocol for communicating with the front end and the back end. You just use one of these protocols and it should kind of work out the box. And then the last bit we add is that we give you, if I do this and then this, and I look at the code, we give you basically a very nice way of turning an agent into an endpoint, for example, a FastAPI app. So you can basically get a ChatGPT-style experience without having to write any TypeScript at all. So here's our agent. In this case, it is going to help people answer questions about our PY AI series. You'll see I've added in here. One thing to note, I said we care about type safety. In this case, the agent is generic in the depths type, which means that inside the tool call here, fetch, we can access the depths, which is an instance of the HTTP connection, and it's nice and type safe. We also added another decorator function here to basically add to the instructions with the current date. Obviously, in this case where I'm going to run it instantly, you could just put the date into the instructions, but if this was going to run for days, adding instructions this way, it gives us, means it will be called on each invocation, and yeah, then we register a tool. It's all type safe, so this run context is basically injected into the function call, but all other parameters turn into parameters within the function. If I had a doc string here, that will be extracted and turned into the description of the parameters for the doc string, et cetera, et cetera. But actually, most of the utility for this agent comes from here, where we register a FastMCP server. So as well as tools, we have tool sets, which as well as you might predict, more than one tool, they can be dynamic. So you can add and remove tools as an agent runs. And obviously, the most common type of tool set is an MCP server. And so we're going to add an MCP server running over streamable HTTP with this line of code. And I will quickly go and show you the code for that MCP server. So it is FastMCP. And we register this one tool, which effectively searches through some FAQs about Pydantic PY AI events. And so you don't need to read all of this, but this was me, in fact, getting Claude Code to generate some possibly right, possibly completely wrong FAQs, but they'll do the job for here. And so all we're doing here is we're using BM25 to search through them. So effectively, what this does, what this combines together to be is one tool that gets added into the context of our main agent, so that it can basically look up information about the event series. You will see over here where we have the where we have the MCP server running, although it's running remotely on the FastMCP cloud, we have set up Logfire again, and we have instrumented MCP, so we'll get distributed tracing. So we'll see within a single trace calls both to in our local agent running and the remote FastMCP agent. So the other bit here is the server itself, which is ultimately just a Fast API server. We do a bit of stuff here to allow you to switch model. You probably wouldn't want that in a production application, but it's quite neat that we basically allow you to configure how the agent is going to be used, what model it's going to be used, yada, yada, yada. But the two interesting bits are here. So this is the actual endpoint for doing the chat, and we use this Vercel AI adapter to get the input stream and convert it to the data that the agent wants to see. We take state from Fast API and use that as our deps here when we call the agent. And you see here we're basically passing agent into our Vercel AI adapter. And this thing is going to take care of translating the streamed response you get from whatever model we're using to the Vercel AI protocol stream, which in turn is going to go to the UI. And so if I stop talking and actually go run this thing, I'm just going to run it with UV acorn. Nothing very interesting to see there. And then I remind myself of where it's running. You get like ChatGPT-style interface. None of this is our hard work. This is all the components built by Vercel for their Vercel AI front-end elements. And so if I ask this, for example, when is the event in New York? It may or may not succeed, but you'll see it going and running tool calls, getting the response, thinking about it, and then you see, so it's told us when the event is, and we can go in and look at the particular tool calls and what the parameters were and what the return value was. We can also go over here to Logfire, and you will see, we now see the MCP server running, incoming HTTP requests, but most interestingly, if we open this particular trace, you'll see we made if you look here at the agent run in particular, you get a good summary of exactly what was going on. You can see the exchange with the LLM. Obviously, in this case, we've got that on another screen, but if this was running somewhere, you wouldn't see that. We also have stuff like token counts and cost associated with these calls. But the powerful bit, of course, is that this is general observability, so we're not just instrumenting our AI calls, we're also instrumenting anything else we do. So if we had database calls, you would see them in this trace. If we wanted to instrument, for example, outgoing HTTP requests, we could do that very simply. We would just turn on instrument HTTPX, restart my server, and we could go back over here into chat, for example. Let's change model for the fun of it, and let's say you saw we registered that fetch tool, so the agent can use that to go and get information from Luma. So we say get details about the event from Luma. Miraculously, if this is going to work, I'm almost exactly on time, which means it probably won't. I can't spell event properly, which isn't helping it yet. You see it's made the fetch call, and when GPT-5 decides to respond, we should get some details. But if we come back over here, even as the trace is running, we can look inside in Logfire exactly what's happening. So you can see we had that request to Luma. You can see the headers, and you can even see the response body here. No, you can't, because it got scrubbed because it had the word session in it. But if it had not been scrubbed, you'd be able to see the response body here. We could switch off scrubbing if we wanted. And GPT-5 has either died or decided that it's going to take a very long time to think about that response. I think it has died for some reason. So on that note of failure, I will finish and hand it over to some questions.